How's everyone doing this afternoon? Oh man, look at that. Last session of the day. This one's going to be a little bit of a doozy. I've been hearing that there's been lots of feedback on how managed availability could be a little bit simpler. And I think that this is just more fuel to that argument. I don't know if it helps opposite, but we'll see. So my name is Charlie Chung. I'm a program manager on the Exchange Data Center team, primarily working with monitoring and data insights and data analysis. And so today what we want to cover in this session is what do we really do when we troubleshoot a managed availability alert? Now in the past when we presented this, we kind of gave the overall overview, the architecture, some of the thinking behind it. But what I wanted to do this time is sort of just walk you through kind of how what our mental model is for managed availability when we look at it, walk through one example in great detail, which at least you'll see us beat down the path once, and then hopefully you'll kind of see how it gels together, and you can actually do some of your own exploration and see how it kind of fits together. Now I'm going to fess up in the very beginning. So our documentation is definitely not complete with managed availability. I'm sure it's frustrating to go see an alert, go to SCUM, click on the link, and it just says, we don't have documentation. Go figure it out. Not that helpful. The other thing is that I'm sure many of you have experienced how when you look at managed availability, that's a lot of information. It's a lot of data. And partly it comes from because we started off with a service-first mentality, and because we have, I don't know if you went to the data center session before this one, we have many subsystems that actually do a lot of pre-processing of the data. What you see sometimes is the unpre-processed version of it, and unless you know how to kind of fit the things together, it can seem overwhelming. But what I want to do is at least establish some common ground with you guys in that, in the service, we both have the goal to make our users happy and productive. That is what our main goal in basically revamping the monitoring system is. We wanted to make sure that it was always about preserving the user experience. And in the past, in some of the models that we had, we were very good at understanding where in the code if there was a problem. But we didn't really know, well, if it says that the categorizer is broken, can users send mail or not? What's the real problem? So with managed availability, we actually flipped the model and wanted to start with a very customer-oriented view of the world so that we can always answer the question, are users impacted or not? And you'll see that influence throughout how we approach managed availability. Now, one of the first challenges, though, if you're just installing something brand new, you're looking at managed availability, you have your SCUM system, you kind of can read the documentation. It says it's so simple. You just run get server health. It can tell you exactly what's going on in your system. Well, sometimes when you run get server health or even get health report, it can feel like you can't really see the forest through the trees. For example, I'm just showing you, I just did this on one of my test topologies on the CAS server. When I did get server health, it returns about 541 different health sets. It's like, really? Wow. I mean, I know that Exchange is a complicated product. I actually got my Exchange architecture poster. I think you all got these in your smelly bag. Is this really 541 different health sets? And it's kind of weird when you go and run. I'll just switch over to my test box here. Let's see here. Right, it can seem you just want to get an overview of is the system healthy or not. And when you go in there and you run this is actually get health report, which is actually a little bit better in that it aggregates the health sets together into some grouping. But if you ran get server health, just do this right here. So I have two boxes. I set up one CAS server and one mailbox server, and this is my CAS server. So I'll just do that. HB 21. I'm a really slow typer, so luckily I do have most of the longer type stuff I can cut and paste in there. But you run this, and it's like, okay, great. What's the health of my system? So I think one of the things, though, is that we had this notion of we did have the 4 categories of you can have customer touch points, you have your server components, you have the server resources, you have your dependencies. But when we designed the platform, we wanted to make sure that you could build any type of monitor in it. And our team did. They built all sorts of stuff in there. But actually, a lot of it is really more to automate some things that are fairly well known. And so in actually looking at the various health sets, if you looked at those 541, there's actually a lot that you can filter out. I don't know if Dimitri covered this in the HA one. Did he cover this a little bit? But there are a lot of health sets, when you actually look at them, that they actually track just some of the stability monitors that we added to the system. There are things that watch the services, processes, app pools to see is the service hung, is it crashing a lot, is it taking up too much resources? And what it does is it allows us to then go quickly, recycle those services, and then it resets everything back. So it'd be very rare for you to have to go and look at a persistent failure in one of these monitors. So we have, like I said, they're listed here, the crash event monitors. We have these Watson ones and those type of things. If you filter those out, that actually removes a lot of that cruft out of get server health so that when you look at it, you can actually filter down to a somewhat semi-rational view. Now, the other thing is that you may have noticed some health sets that don't make any sense, like something called central admin. If you went to the previous talk about the data center, they were saying how central admin is a data center only service and we're not shipping those things on premise. That's absolutely true. Then why in the world do you see a central admin health set in your on-premise environment? So there is some cleanup stuff that we still have to go do to make sure that a lot of these health sets that aren't even relevant in the on-premise world, that you don't see them. However, there's a simple way for you to filter those out. If you also filter out any monitors or any health sets that only have a maintenance failure monitor, it's one of two things. It's either it is a data center only component, so that's why it never really instantiates a set of monitors that you would see in your environment. And it could be that you're not using that feature. So again, you wouldn't see the subsequent real monitors behind that. And so just to show you an experiment, how you can see how this does really, really filter down the list, what I did, let's see here. So I like when I look at the get server health, there's a couple of columns that are more interesting to me than the default. Like this one actually shows you the health group and those type of things. So this is the same list, the same 541, just formatted with a little bit differently. So if I take that, I'm going to dump it out to a CSV file, and I'm going to put it into Excel. This is the one great thing, is that managed availability does have a tremendous amount of data. And so you could actually learn a lot about the system. It's just knowing a little bit now where to look and how to parse it. So if I go onto the D drive where I dropped this file, I'm just going to open this thing up. Let's see here, there's all my health sets. I'm going to copy this. Now what I did was I created this template file, which we'll post after the session. So what I did is I actually created a template file where, like, Excel has this really good function called VLOOKUP, where you can actually start mapping different parameters together. And so just to help in that interpretation, what I did is I created a lookup table which has some extra properties on how we think about things. One of the ones I'll show you, just showing you right now, is like which ones do you include and exclude. So if I actually put this in this table here, I need to convert this thing to columns. Yeah, looks good. Yep. Get rid of these. What you'll notice is it filled in. When I pasted the data, I only filled it up to target resource. It actually filled in a couple extra columns for me, whether I should include or exclude this as a real health set to go look at, We actually are, we'll get into this a little bit later, but you can actually, when you actually look at the health sets, there is an organization to these health sets that when you start looking at them, you can look at them at the various layer that they actually live in. And why that's relevant is because different layers or different groupings actually have different models behind them. They're not all the same model like we were presenting in the past where you kind of seen the 4 different probe types. That's only relevant to one model. We actually have several models behind managed availability. So when you do that, and if I actually do the exclude and I say don't include the yes, so actually exclude those, it actually goes down to 78. So 78 is the real set of health sets that you actually need to go look at. So I'll actually go and put those back. I'll show you what I mean, but what that actually took out. So if you look here, there's a lot of these. I'll sort this by, let's see here. I actually have it sorted here. So you can see the Exchange crash event. We took those out. There are these long-running processes. We'll take those out. The private working set. I'm actually putting those back in so you can see what those are. So when you look at those, these are all these health sets where they don't really help you troubleshoot anything other than what we use them for is when we see those triggers, we have a responder that hooks up to go recycle those app pools or those services, and it just takes care of themselves. So it kind of is just clutter when you're actually trying to figure out what's really going on. When you take the opposite of that, these are the real things that are telling you what is the true user experience. So if I go back to my ones and go exclude those, I can now actually see, to sort these. Well, it's already sorted. Great. So I can sort those and I can see. So here are my active sync. So on the front end, I actually have the 4 probe or the CTP probe, the proxy test probe. And it's actually organized in a nice way. Now, what I actually did is I put both the mailbox server health sets and the CAS server health sets together. And when you look at it that way, you kind of get the full picture of what's going on. So you might recognize this picture from this is what we presented in the past. This is how we actually treat front-end protocols as a health set. And this is where this model is actually relevant, because when you filter it down, you can actually see, oh, here's the protocol 1 probe, which maps here. So this is where we're actually testing the full functionality of that probe on the mailbox server. Here's the self-test probe. So this is the one that's just testing the protocol head, again, on the mailbox server. The proxy test probe, which is on the CAS server. So this is where just making sure, is that HTTP head up so that it can go and redirect that proxy request. And then you have the CTP probe. Now, what you'll also notice, so this is the general model for almost all of our protocols. So you'll see we have active sync. Now, one thing that's unique is you'll notice AutoDiscover, it only has 3 of it doesn't have a deep test probe, which makes sense because AutoDiscover, you don't need to log into the mailbox to actually test its functionality. So you don't need that deep test probe, but the other 3 are still good. It's good to know that you have this end-to-end probe. It's good to know that the proxy's up, or it's good to know is the actual protocol head on the mailbox server, which actually contains all the real business logic, because the CAS server now is just a very simple proxies, knowing that those things are broken. And once you have that, when you're analyzing the health sets, and if you're not having to look at all these process crash, long-running things, it actually gets a lot simpler to understand, okay, if something is broken, generally that CTP probe is going to be broken, but then you can actually figure out which substage might be the problem and isolate it down to the machine. And I'll talk about some of the others as well when we get there. But again, so just that's one way where on the mailbox server, it's actually a little worse. So on the CAS server, there's about 540. On the mailbox server, if you didn't filter those out, you'd see almost over 950 different health sets. But when you filter those down, it drops down quite a bit to a set that actually makes sense. So health set models. So how should you think about these health sets? Again, like if you go back to that architecture diagram, the architecture poster actually organizes Exchange very well. And the health sets you can think of also sort of kind of collectively cluster in the same way. So we just saw how the protocols, they have the model of the 4 types of probes and how we have this defense in depth architecture where we have the end-to-end probe, and then we can break it down by layer of which, is it a front end or is it a back end server that's broken? And you'll see that these are the front end protocols where they generally follow that model. Now, there are 4 others that you actually have to think about, and they don't necessarily follow the same models. You can't think of them in the same way. So storage, if you went to the HA talk, I think Dimitri gave you a little bit more insight in how the data protection and the clustering health sets, how they really work. And the things about the storage health sets is they have a very different problem that they're trying to manage and detect. Right? The client protocols, the transaction is, can I hit a front end, get redirected to a back end, log into a mailbox? The storage health sets are all about protecting that database. So they care about different things. They want to know, what really is the disk health? What is the cluster health? What is the latency, RPC latency? What is the disk space? So there's a different model there on how you think about it. And in terms of what breaks in what order, it's a little bit different. So you can see here, it's like if you want to think of it in layers, you have clustering and data protection are kind of at the bottom. And then you'd have the other things that are kind of built on top of that. Now, Mailflow, again, is also different. So Mailflow, its job is, it has a lot of different characteristics where, Mailflow is not as interactive as, your OA login, right? Mailflow is based on a store and forward design. So the ability to queue and those type of things are really important in Mailflow. And then the other part of Mailflow is all the agents. So there's a lot of hooks in Mailflow and understanding, is mail flowing through? Are the agents processing everything as expected, especially like the compliance ones or the transport rules? Those are important to know that they're working. And then the other thing that's interesting about Mailflow is, a lot of times you can have, for some reason, some piece of mail might have some content conversion problem, and it can clog up the pipeline. And so those are the type of things where it's really optimized to detect, how do I keep the pipe clean, it's flowing at a consistent rate. So the other two that I'm not going to really drill into them today. In the future, we'll have more talks on this and more documentation. That they have a different model are migration and then what I'm calling the fabric bucket. This is kind of like a bunch of things that really are infrastructure. So the idea is that if you see your protocol, your storage, or your Mailflow one broken, the fabric bucket, if something in there is broken, it could affect one of those three. And migration, like when you think of migration, it's not like this core. It's not core to the user experience, but it is a key piece that's on the side that has a job processor that's constantly running to make sure that it's moving the moves that you need to if jobs are stuck. So it's optimized kind of for that job workflow. And then the fabric there are some key pieces here that we have in the fabric. So the Active Directory, which I'm sure many of you are aware of the last CU, we had some issues with the Active Directory health set and being a little bit aggressive in how we're rebooting servers in specific topologies. But the Active Directory health set, Exchange is very dependent on the AD. We use the AD for both configuration, we use it for authentication. So if Exchange can't talk to the AD, Exchange really can't work that well. In the past, we used to say, it's like peanut butter and jelly, right? It's like Exchange and the AD. We're just linked together, it works well together. You can't go one without the other really well. So with the AD, what we're checking to make sure is, can we contact both the config DCs and the rest of the domain controllers? But then there's another layer to it. So we have a service called the Topology Discovery Service. And what that does in the past, I think you might recognize as the AD driver, we have a layer that helps us understand what is the best domain controller to go hit. So there's two ways that we can be impacted. One, if the Active Directory is unhealthy, we could have an issue. But also if AD driver is having an issue and it's not able to actually properly calculate what is the healthiest DC to go talk to, that can be an issue. And so that's what that health set is optimized and can help you understand is it the AD or is it the topology discovery that we're having issues with. We also have, EDS is an important component that we have, which we rely heavily on in managed availability. The reason why I've starred EDS a little bit is if you ever drill into the EDS health set on premise, what you'll find is the EDS health set has over 100 different monitors inside of it. And so, again, this is probably where, because in the service we have a lot of machines that can pre-process what we're looking at, works great for us. But if you're thinking from an on-premise perspective where, technically if the EDS health set flips red, when any other monitor flips red, you wouldn't get an alert. It's a problem because what actually has happened is we've grouped several different monitors that aren't even related to EDS, but they use EDS to detect things that are rolled up under there. And so we're working on getting that straightened out and moving those out. So just to give you a little bit more context on that, EDS is our perf counter processing engine. So it goes, and what teams can do is they can say, well, if there is, like in the ActiveSync case, they have one where if it's greater than 500 requests that are queuing up, they'll flip a monitor. And so that monitor is actually under the right health set. But there are others that are for other components, but they're rolled under EDS. So technically, when the thing's cleaned up, what you see is the thing that we need to monitor in EDS is EDS working? And so we have things like, is this EDS service running? Is it configured properly? Is it rejecting these triggers? Because that's actually how we process it. Is when we process the perf counters, it'd be really expensive for us to stream raw perf counter data into active monitoring. It would just overwhelm our Crimson channels and event logs. So it's based on a trigger mechanism. So what we do is we watch these events. When it hits a threshold, it'll hit a trigger. EDS knows what that trigger is, and then it logs sort of like a probe result into the managed availability pipeline, and then everything proceeds from there. And then we have disk space. So disk space is some things that we manage. Now, what you'll notice is missing from here is the network health set, because that's visible in the on-premise product, and that seems useful, because if the network is broken, we're probably broken. The thing about the network one is that the network health set is actually very specific to the data center. You'll notice if you actually drilled into those monitors, the monitors that we actually built were to check to see if do we have a host name associated to every NIC or every IP. Do we have this thing called a MAPI NIC. So just in our network architecture, we used to have a different MAPI NIC for our clusters and then a NIC to go talk to other things. And so these health sets are looking for these MAPI NICs, which aren't really relevant in your environment as well. So they automatically just don't really detect anything. So that's another one that you can go ahead and ignore. So again, to give you again the big picture of the protocol ones. The protocol ones are actually following that defense in depth, multi-step probe design, and it is great for us because this is where we really want to make sure we detect all customer issues, and that's what the CT probe helps us do. So even if we've missed a case, ideally, like there's some component or some check that we didn't add, if the customer experience is broken, that CTP's probe's job is to catch that. So what you'll notice is the CTP probe doesn't necessarily have a lot of responders hooked into it because it doesn't have a specific target. Like it won't know if it should go reset the app pool. It doesn't know if it should go and fail over the database. But what the sub monitors do is they are targeted. So if you actually go and look at the target resource, you can see that they're targeted to specific resources like the app pool. So it knows like that is what the responder is going to go act on. And again, when you look at it, it makes a lot of sense when you do the get health set against those protocols because you can see how the actual probe design lines up with the overall framework that we had. And the timings of how things will fire are actually the same. Now, what you'll also notice is that there are some health sets that have these things. There are two additional types of triggers. So the ones that follow the probe or the synthetic patterns are the ones that fall into 1 through 4. But you can also, like I said, have an EDS trigger. And then the third one is there are teams that have encoded specific events that they want to look for, that they don't need to wait for measurements or they don't need to wait for synthetics to fail at a certain rhythm, that they can just fire immediately. And so that's the third type. So what you'll see in the spreadsheet that I'll share with you is when you look at how this thing breaks down, you'll see the 1 through 4 probes and their types. You'll see some are called protocol counters because they're based on a specific counter. And then there's the protocol events. So it's a specific event that gets triggered, and then that starts the whole responder chain from there. So storage. Again, I'm not going to go deep into storage, but like if you wanted to go and look at, so if there isn't a problem with the client protocols, which is great, then you have sort of the underlying infrastructure to go manage. And Dimitri went into detail talking about the data protection and talking about the one copy monitors that we have. Also with clustering, like one of the things, if the cluster hang monitor is hung, that means we're not going to be failing over. So I won't go into detail on those. But then, like I said, on top of those are built a couple other components that the thing is that each one of these also have their own unique sort of model how to think about the groupings or the organization of their health sets. And so there's store. Again, store is very designed to think about on a per database entity basis, how healthy is that, and should they fail over? Should they go inform data protection to fail over? The events assistance is a mechanism that we have inside Store. So this is kind of like this job engine or this trigger engine where a lot of things happen based on events that you are doing in your mailbox. And then it can say, OK, great, I need to go send an OOF, or I need to go trigger this inbox rule, those type of things. Actually, inbox rules are moved to transport. But similar to those type of things. And then you have public folders and site mailboxes. Now, those models haven't been full. I'd say like we have some simple counters or simple event checks that we have to go see if those things are working. But again, they have a different model than Store. Store is probably one of the more deep models that we have in the storage section. And then the other one is Search. Search has also a really, really deep model around how do they go manage the indexes, the index nodes, and how do they figure out if the crawling is actually working. So there's a model how to think about it, when you're seeing anything in the search health set broken, what's the order and what's the layer that you should start working at to kind of troubleshoot there. So the next one is Mailflow. And so Mailflow, I would say, has the most monitors, I'd say, of all of the groupings that we have. But when you look at the model that they had behind transport was really designed to think about, is the Mailflow pipeline flowing as fast as possible, or as fast as the SLA is defined? So you'll notice that they will have they're really counter-type triggers, but they're all measuring latency. So that's an important model. So when you see latency is broken, that's kind of like their end-to-end measurement. And so like, OK, the transport pipeline is not healthy, but then we have to go figure out, well, why? Why is the transport pipeline not healthy? That can happen in one of three stages. So you have the ability to receive mail. So that includes the SMTP protocol head and as well as the store delivery head. Things can happen in there. The reason why things can happen there is they actually do have event hooks where you can actually create transport agents and do things to mail messages as they come in. Or there might be, especially on the SMTP protocol side, if the SMTP configuration is not exactly right, whether it's misconfigured accepted domains or certificates or just the verbs that you'll allow, you could see some delays that are happening there. You also have the routing, so when mail comes in, it needs to get routed and figured out what is the next best hop, or if I need to do a DL expansion. There's a lot of things that can happen there, and again, those have event hooks, and then there's delivery. So getting into the store or actually sending out to the internet. And again, there's all sorts of reasons why things will get in or not get in, but you can start looking at the queue, monitoring the queue length, and understanding what is really the mail flow latency. So what you'll find is they have a lot of things that are based on queuing, based on SLA latency times, and then these specific components, whether it's submit, route, or deliver. And that's a way to break it up. Like the Mailflow one is the one that seems like it may be the most overwhelming at first because there's so many. But a lot of, like when you break it out here, what you'll notice is there are a couple that monitor these core functions. And then what the transport, the Mailflow team has done is they've actually added a lot of configuration checks to make sure that the pipeline is configured correctly. So they have things like, do you have required TLS configured? Are your certificates right? Those type of things. Are your accepted domains configured correctly? So you can think of it as, generally, once you configured it once, it works. Ideally, unless someone goes and revert that configuration change, you would never see that monitor flip. So it doesn't have to, you would think that these are not break events that would happen very often, but when they do, they are critical to the pipeline. And then the agents. What you'll notice is if you look at the transport one, they have a lot of monitors that are related to specific agents in the pipeline. And what they're actually doing is they're really looking for crash events. They want to know when a single message is crashing an agent over and over again so that they can go and poison that message or do something or take that thing out so that the remaining messages can just flow. So that they're not really testing the specific agent functionality because that would just be really expensive to have to continuously do all those agent functionalities over and over again. So, like I said, let me show you here. So what I've done in this Excel spreadsheet is I've broken those out so that these are broken out by the different health sets already pre-filtered out. So I filtered out all the noise ones that you don't have to worry about. You can then kind of filter it down by the component if you want to. And then there's also a scenario section is there as well. Like I said, I won't go in too deep into this. We also have another Ask the Expert session tomorrow morning. So if you have any other questions, we'll have folks from the monitor team. We'll also have folks from the HA team, like Abram will be there, that can help and answer any more detailed questions. But again, like I said, when you look at the target resources, it's really very database focused on the storage health sets. That's really the entity that you're managing. And if databases are healthy, then it's really the underlying infrastructure that ensures, if there is an infrastructure problem, you can move those databases appropriately. And then there's the Mailflow ones. And like I said, the Mailflow ones have quite a number of different health sets. And I didn't even include the hygiene ones, because the hygiene ones, there are even more different monitors that they're looking at, because there's different things that you want to understand, like are you getting signatures and those type of things. So probably for this discussion, the transfer one I'm leaving as another day, because it'll probably take another hour just to go through and walk through some of the transport scenarios. And then here's the fabric ones. So with the fabric, like I said, here's the AD ones that we look at. For monitoring, we have a couple that we look at, because if monitoring is not running, or the health manager service is not running, managed availability isn't actually processing anything. So this is a key thing that we want to go and monitor and make sure that's always running. And that's a key component. And then our remote monitoring health set is to make sure, how do you know if monitoring is running? Well, we have a monitor of the monitor. And we kind of use a buddy system. We call it remote monitoring, where what it does is when the service starts up, it can kind of send out a request and say, hey, I need 3 buddies to watch me. And then if there is any other servers available, they'll go and start watching them. So that way, even if that single box starts slowing down, or it's not processing work items and probes, or running probes, or running monitors, that other remote box can go and say, hey, I'm going to restart your service. And generally, everything can get reset, and then monitoring can start processing again. And then what I didn't really talk about that much is we have these user throttling ones. So this is where we have workload management. And what it does is it makes sure that there's no one protocol that's going to overtake all the resources on the box. And so sometimes what you may see is, when a client is trying to connect, they may be rejected based on throttling policy. This should be flipping if they're seeing that happening at an excessive rate. So let me go back here. So that's kind of like the high-level mental model. So if you want to kind of break down, so coming from that big, huge monolithic list, you can start to divide and conquer a little bit. You can kind of break this up in your mind and be able to focus on these different things. And I think the big insight you guys should really take away is, this is not one model. In the past, I think that was maybe a miscommunication that we had, is that people thought this was, that picture was, this is how all of managed availability works, and it's not the case. It's only for protocols. And these others have a different model, which we'll document and help you out with. So once you have that, I think one of the things that, it's great. You can run get server health. You can understand the health of that server. But if you have more than, I would say, 2 servers, who wants to go and run get server health on every server? How do you really get to this summary view of the service and figure out, is Exchange working as a whole? And how can you do that in a scalable way? Well, the tools that we have it on a per server level with get health report. So that is a roll-up of all of the health sets and its related monitors into a much smaller list. And I think when you apply some of the filters that we have, that will also filter down that list even more. So you don't see the data center specific ones. You won't see the ones that aren't really instantiated for your environment, because they only have a maintenance failure monitor. So you'll get a much cleaner idea of what's going on. But really then our story to get the unified view of the service is utilizing the System Center management pack. And what the System Center management pack does, it's still useful in that what we're doing is when we are flipping the health states and the health sets, we're then rolling those up through events in System Center into the console so that you can get one unified view of your environment. Now, it doesn't give you every single detailed monitor state, because we felt that was a little bit it would be over abusive of SCOM, where really if you're managing at a health set level, the idea is you're really managing your environment as groups of servers, whether they're DAGs or whether they're arrays. And what you want to know is this DAG or is this array healthy or not healthy? Because the idea is that even if a single server might be unhealthy, your overall availability can still be good, because you've either offlined that cafe server or you failed over that mailbox server. So your users, their user experience is still good, there's no reason to go wake you up in the middle of the night, but you still need to go and put those machines back, and that's what the SCOM console will help you go do. So this is the big question we always get, is like, what does unhealthy really mean? How do you really decipher that? Do you guys know what this is? This symbol? It's actually for an EKG. Like when they take an EKG of your heart rate, they actually are measuring these specific points. And by doing that, they can actually come to really good clarity of how healthy your heart actually is. And you can do the same thing with managed availability. By looking at certain things, you can get a good idea of what is really going on. So here is sort of this, troubleshooting framework you can use when you're thinking about, okay, so once I get this health set that has this monitor that says unhealthy, what do I do? Well, your starting point is the monitor. So the monitor is the central thing in managed availability. When you're running get, whether it's get health report or get server health, what you're actually doing is you're getting a list of monitors. And the monitor is basically the analysis or the piece of code that is looking at the measurements and deciding what healthy or unhealthy means. So when you're looking at that, you have to start with the monitor. Now, the first thing that you could do is just say, so fine, we may have flipped the monitor, or the monitor may have read a certain set of measurements and said the system is unhealthy. By the time you get the alert, the issue might have gone away. It might have been some network transient issue or whatever. So the first question we generally say is it still broken? Well, how do you figure that out? Especially if like all you have is the monitor. What is this monitor looking at, or what's its measurements? So this is how you can do it. So this is where it gets deep, because you're really gonna have to dig deep on this one. But let me just walk you through this thing. So I'm gonna go to my demo box here. Let's close this out. So what I did beforehand is I actually broke ActiveSync. I just broke ActiveSync because alphabetically it was at the top of the list. These guys saw it, right? It was healthy, it was working good, and I broke it. So if we went and actually did get, let me just follow the cut and paste stuff, that you don't have to watch me finger type. So I'm just going to go and look at what are all the health sets that are unhealthy on this Caffe server, or this CAS server. So you can see here that I have both ActiveSync and the ActiveSync proxy health set that is broken on this box. So, okay, great. What does that mean? So what should I go do next? So what this does, so again, health sets are groups of monitors. So there are generally a couple of things that could be attributing to why this thing is unhealthy. And what we do is we take a worst of evaluation. So if any one monitor is unhealthy, the whole health set's unhealthy. So let's just look at the ActiveSync proxy one, because that's probably the most actionable one that we can go look at. So if I do get, let me just cut and paste this thing. I'll do get server health. We'll look at the ActiveSync proxy health set. And we'll go look at what are the monitors that are actually broken. And again here, what we have is there's the ActiveSync proxy test monitor. And what you'll notice is for most protocols, they all have these. And this is because what they're actually doing is testing the proxy head on that Caffe server. So when you're coming in for this protocol, can I redirect it to a backend and actually process this request? So that's unhealthy. Well, where do I go from there? So I don't really, great, now you just told me a little bit more detail that something is still unhealthy, but it's not yet actionable for me. So how can you, if we just want to know, is this problem really still happening? What you want to get to is, so we know what the monitor name is at least, right? So if you looked here, you know that it's the ActiveSync proxy test monitor. So there's a way that we can work from the monitor and learn, well, what is the actual measurement that is associated with that? And so these are utilizing, looking into the event log channels, we can actually find a lot of this information. I think Abram actually posted a lot of the scripts in the past, so some of these might seem familiar. And I'm just going to go and cut and paste these in really, really quickly. Because there's a value called the sample mask that we want to get to, essentially. So what it's doing is we're going to go into the monitor definition channel. So these are where all the monitors for the server are defined. We're then going to go look for that monitor. So we're basically doing this, where name equals that ActiveSync proxy test monitor. And we're going to look for a field called the sample mask. And what the sample mask does is this actually tells you what is the measurement that's actually this monitor is looking at to go trigger and know that I'm healthy or not healthy. And what you can see here is it's actually the ActiveSync proxy test probe. So it's good to, you can probably assume that if you know the monitor name, you can just replace monitor with probe, but sometimes that's not necessarily true. So this is one way you can just double check to make sure this is the actual probe that you can go run. If you're actually interested in seeing what all of the properties are on the monitor, you can just do this, and you can actually see all the properties on the monitor and see all the settings that they have there. This actually is useful, especially when you want to create an override. If you want to override this monitor or this monitor definition, this information is actually useful. So now that we know, OK, great, so we know the probe name. Now let's actually go, one of the things we can do is we can actually rerun that probe. There's a command called invoke monitoring probe, which will basically do the same thing that this probe does. But what we'll do is we'll be able to go and output the output of this request. And we can see what is it really happening. So these probes are running on an interval. And you can actually go, if you wanted to go into the Crimson channel, you can actually go look for the specific probe results. But this is just one way where you can, what we like to have on the engineering side is we want a live repro. Like once you can repro it, then you can go and make your tweaks and figure out, did it fix it? Because you can always rerun this repro and verify if the fix has been made. So what this is doing is this is going through, it's reading the probe definition that we have. So in the probe definition, we know what is the target mailbox that we should use for this probe based on this machine. And you can see here, here's the probe results. So this is actually what we get back in the database is we get all the timing and all these things. Here's the result type, though. It's like basically it failed. OK, so you know that this issue is still reproing. So now what? We still haven't really fixed the issue. So if we go back to the map, like ideally, if this, we've been talking about managed availability and how managed availability is supposed to solve all your problems for you and should have automatically fixed the problem. So what happened? Like especially this one where it's an app pool, it should have already fixed it. How can you go verify, is it the problem with something in your configuration that's broken, or is your responders broken? What's going on? Well, then the next question would be, well, which responder is supposed to run for that monitor? Again, we can go back through, and you start with the monitor, because the monitor is the anchor point, or the anchor data point that you have. We can then go back through the definitions and discover what is the responder for that monitor and what should it have done. So let's go look at that. So again, what we're doing here is we are just going through. This is more like of a one-liner. We're going to go through the responder definition channels, and we're going to go look for the responder definition for that event. Now, I'm just using PowerShell because it's really easy to do. But just to show you, it's essentially the same thing if you just went to the event log. I'll open Event Viewer and show you how you can kind of do the same thing here. So in what we built managed availability on is basically event log channels. And what we're using the event log for is you can think of it as we're using the event log as a database. So we didn't want to have to install like a SQLite or anything on the box and add more resources to an Exchange server. So what we did is we actually by utilizing the event log channel as a database, we can actually then do database-like things. And so what you'll notice is if you go under the application setting of the event log, there are two that are actually used by managed availability. One is active monitoring. So active monitoring is you can think of it as the synthetic transaction platform that is being able to take these measurements, as well as it's also the one that can pull from EDS and actually look at those triggers and produce results. It's also the framework that encapsulates our monitoring logic. So this is where we define what is healthy and not healthy, and teams can utilize that to trigger things. And so what we're doing is with the thing that I just ran on the command line is we're looking at this responder definition. So for every basically active monitoring is broken up into three things. You have probes, monitors, and responders. There's always a definition table. So when the service starts up, we actually go and look at the environment, and then we try to go look at what are the things that we should go monitor, and then we automatically will start creating definitions for those things. And then what happens is the health manager process is picking up work from those definitions. So it says, give me a piece of work to go do. I'm going to go do that work, and then I write my result in a result table. And that's what you see here is the responder result. So it's the same pattern. So if you wanted to go look at probe definitions, you can see how is a probe defined, and then you can see what the result is right in the channels there. So if we look here, what I'm going to be looking for is I want to see where the alert mask is like the ActiveSync proxy test monitor. So again, we got that from Get Server Health. You got the name of the monitor. From there, if you look at the alert mask value in the responder definition table, you'll actually find here are all of the responders that are associated to it. Now, I added this escalation message one because it actually has some interesting information if you want to see what will actually get sent to the event log and eventually to SCOM. But if you just want to get a simpler view of the responders, you take that one out. You can see there's actually 4 responders that are associated to that monitor. And again, this actually shows how we do this gradual recovery. So our first attempt to recover when we see things are unhealthy is we will try to recycle the app pool. And then if that fails, what we'll do is we'll try to take that app pool offline. And what that means is to a load balancer, if it goes and tries to hit that endpoint, it doesn't get a heartbeat back, and it'll automatically go and fail over to another one. So it essentially takes it out of rotation, and it won't impact your user experience. Now you have these other two. So if going offline fails, we'll escalate. So that means create an event in the event log, SCOM will pick it up, and then it'll hopefully inform a human. In the service, what it does, it goes and pages one of our engineers, and they need to go take a look at it. And then we have, even if the offline failed, we do escalate. So in case, if the issue still doesn't get resolved and we need a human to go and resolve it, we'll go escalate. So what we want to understand is why didn't this, so the recycled test app pools, what should have done, did it do it? What should we go do? How do we see what happened there? So I'm just going to go into the event log and show you how to go do that. So you would think intuitively that, well, great. So if I know what this responder name is, I should just search for this responder, copy this thing, this recycle app pool responder in the responder table, right? Because that'll tell me where it is or what happened. Let's see. Let's do a find. See it. Yeah, there's an event in there. And again, so since we're using it as a database, it doesn't look like your traditional event log event where you'd see details here. You actually look into the XML view of it. It's where you would actually see the various different settings. And what you'll notice here is all it says is that, well, actually, if you don't know what you're looking at, this is almost like reading the matrix a little bit. There is a message in here, and this is where the result is what's important. And so it says the result failed, but again, that's not that informative. And so what there's actually is this recovery action log that can give you a little bit more detail. So if we search for the same thing there, you'll notice there that it says here that, oh, well, it actually tried to do it, but the operation was failed because of throttling, especially local throttling. So what we've learned by running this in the service is that self-healing is awesome, but over self-healing is actually not that great. And so what happened in the beginning is we had these responders, and they were running a lot. And they were recycling stuff and restarting services a lot. And what it seemed like is, it didn't feel like we had control over the service. It felt like it could be a runaway train if you had the right cascading set of events that could happen. And so to avoid that, we added throttling into responders so that there is a limit to how many times we'll try a responder before we'll say, finally, you know what? It's probably best to go get a human involved because if we let this keep going, who knows if the thing keeps cascading around the world and servers are going up and down, and our experience will get very inconsistent. So what happened here is that the throttling actually failed, the local throttle. And it's because what actually happened earlier is I actually broke it earlier in testing the demo. I used up the throttle, and then it fixed itself. And then after that, basically the setting here is it'll only fix it once a day per hour. So just to show you that this is true, this will give you some other things you can do with the data that we have. This is a little script that one of our engineers put together while we were here. I was asking him, hey, can you go figure out how to show some visualizations of managed availability? And so what this is we're able to go, he has a script that goes in, pulls the probe results out for the ActiveSync probe. And you can actually see, this is actually what happened, is when I was testing it, I basically broke it. It fixed it, because it broke for a short period of time and it fixed it. And then I just couldn't figure out, I was like, what's going on? I thought I broke it. And then I went and broke it again, and then it finally took. And then you can see how we'll eventually fix it. And then you can see I tested the demo again. So these are some of the things you can do where if you look at some of these probe results, you can actually see over time, it's fairly simple what it's doing. It's just probing the system, and either passes or fails. And based off of some type of measurement or threshold, we'll go trigger. So we know that, you know what, basically, it looks like this would have fixed it. What it tried to do is restart the app pool. That probably would have fixed it, but this would have got rejected because of throttling. If you want to know more about what the throttling settings are, we have this throttling config channel, which actually has all of the various responders and what their local throttling. There's a local throttle setting and a global throttle setting, and what those are. So if we look here, I believe the app pool one is towards the end. Let's see, let's restart service. So recycle app pool. So you can see the local throttle here is, we'll only do it once every hour, and then basically once a day for the local, and then globally, or in the global group. So a global group is like per array or per DAG. That's how many times it'll go do it. So actually, and that's actually what I did. So what I did to break it is I just stopped the app pool. So if I start this back up, that'll probably go fix it. And what we notice a lot in our service, because we have so many servers, and a lot of times some of these servers are hitting the throttle, and we'll see like, okay, an engineer gets woken up, they look at local active monitoring, they go and reset the app pool, and it fixes itself. And it's because we're hitting the throttle. So we're looking at how we optimize that so that we can be a little bit smarter if it's safe to go make that change. So this will eventually go. What we'll see is what we could do is we could go and rerun that invoke monitoring probe. We actually go see it can pass, and the system will come back up. Everything will get back to healthy. But I'm going to skip that so we can keep going. All right. Okay. So let's go back to the presentation. So great. So what we just walked through was, did the responder fire? We saw that it didn't. You can actually see why it didn't fire, especially in the recovery action log under managed availability. And then what we can do is we could either rerun it or just fix it, because I actually stopped it. So trying to restart it wouldn't actually fix it unless you started it. But if even that doesn't fix the issue, what do you do next? What is the next thing to go look at? And so what you'd actually start doing is you'd then start looking at the actual measurement. So how do you go back and actually see what the measurement is? Now there's a great example. I was reading a blog. I think it's from a UC guy or some UC guy. I think that's his blog name. But he had a good example of, if you ever are going to go and deploy a test topology, one of the things you'll run into is the AutoDiscover health set will always be unhealthy if you just take the out-of-the-box settings. And if you follow these steps, you go through this system methodically, you'll actually go and see that there's no responder that's going to fix the issue. But if you go through and you actually go all the way to the measurement, you'll actually see the error in the measurement will tell you exactly why it's broken. And generally, it's broken because you have to set some external URL setting on either OA or ECP. And if you set that, then the thing is good, and then the health set passes, and the probe will run correctly. So that's another example if you have time, if you really want to go dig into it and really want to see, how do I actually go through and troubleshoot this thing? Like I said, I think this is more of, I think you go down the beaten path a couple times, you'll start seeing that the magic that is managed availability is not like that complicated. It's actually very straightforward when you understand, all we're doing is adding A plus B to equal C. And once I think the thing that we didn't really provide very easily in the past was just how could you go take all the right values, add them together to get that logical result. So this is how you would do it. If it's still broken, you can go and basically invoke the probe again, and in that you'll see the exception. You can also, like I was saying, like this is the very scripty way to do it. If you want just the very simple, straightforward way, again, you can just look at the probe results here, and you can search for the specific probe that you're trying to troubleshoot. You'll be able to find that here, and all the probe results will be here. And generally, you'll see some type of context, or there'll be an exception or error field that will have more data that you can go look at. It's generally these ones. It looks like this one passed. The other thing, so I will give you another little nugget. So when you do look at the probe result table here, this result type is really the thing that actually says what happened to this probe. Now, for the most part, if your system is running as normal as possible, what you'd see is event result type 3. 3 means a pass. So we actually try to run the probe. It actually succeeded. 3 is good. The other value you would most likely see is 4. So if you see 4, that means it failed for one reason or another. but it's probably a failure in something specific to that application, whether it is ActiveSync or OA or Outlook. If you see a 1 or a 2, that's generally a monitoring infrastructure problem. A 1 is a 1 a timeout? I'm asking one of the devs. 1's a timeout, which means we actually tried to go run the probe. The probe took too long. So it might be a perf problem. It might be that we're running behind in the framework and processing the jobs. But whatever the reason is, we timed out. We couldn't finish it. That's generally a monitoring infrastructure problem where recycling the Health Manager service will fix it. And 2 is a poison. So that means we tried to go run this probe, and it started crashing too many times. So we had to go poison this result. So if you see a 1 or a 2, you can sort of bet as a monitoring infra problem. 3 and a 4 are normal cases where you can go ahead and kind of start troubleshooting the actual app at that layer. All right. So this is what we did in troubleshooting, like did the responder actually run? So this is where, like, I hope I saw someone trying to take a picture. You don't have to worry about taking a picture of all the slides. Everything that I typed out is actually all on the slides here. So basically, to go and find out that responder, again, this is the first section is just the PowerShell script to go and pull the data out of the event log. And so one of the things about the definition channels are that the number of entries in there are finite. So it's very different than when you look at the result channel. So it's because we only have a certain number of work items that we'll go create. And we'll always go replace the work item when we recycle. So that sort of gets cleared out, and then we have a new set of work items in the definition channel. In the result channel, that is not finite. Like, we are always logging the results. So if you ever try to go and do the same thing against the result channel, your PowerShell is going to be running forever, and you'll probably fill up all the memory on whatever box you're running on. So you don't want to do that. With the results, you probably want to put some type of time filter so you can actually get only a certain segment of results out of there that then you can put in memory and start manipulating. But for definitions, like I said, those are very finite. So what we're doing here is we're loading those into memory, converting them into an object that's easy to manipulate, and then you can do simple PowerShell filtering to go find specific entries into that table. And again, so once you have the responder, then you can start looking at the responder result table. If that'll just basically tell you, did it pass or did it fail? And then you can look at the recovery action result log table to actually find out any more additional information. OK, so what if the problem isn't that easy to find? So now you see that this is generally the case where you see the CTP probe is failing. So if you remember, if we go back to this picture, how the protocols work, the CTP probe, or probe number 4, starts at a front end and logs into a back end to make sure that end-to-end things are working correctly. So if this CTP probe is failing, how do you know which back end it was trying to hit? Or how do you know which mailbox it was trying to hit? So there's a systematic way that you could do it, and then there's an easy way you can do it. So just like in math class, we're going to go through the hard way first, and then we'll show you the easy way, how to go do it. So the way you go do it is, again, how you can do this is we can go and load up the definitions for the probe. So this is going into the probe definition table, loading up all of the probe definitions. If you have that, actually, let's just do this one. You'll get the properties for that probe definition. So let me just go do that here. So what we're looking for here is I'm looking for any probe that basically has the name ActiveSync CTP probe. What you'll notice is here's the definition. And in the definition, we actually have the account. It's the health mailbox, blah, 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 long number at my domain. Now, the one thing that we've tried to do, so this is, you've probably seen these health mailboxes. If you ever looked at the raw Active Directory, you can actually see them. In Exchange, we attempted to hide them, so that if you just run get mailbox, you don't see them by default. They're often the MISO container, so you don't have to worry about them. But some administrators are worried about these mailboxes. And the way that we designed them is that these things are supposed to be self-sufficient. They're out of the way. They're low permissioned. They don't do anything other than doing synthetic transactions. You'll notice that there's no password in our definition. That's because what we do is we actually regenerate the password every single time the service starts up. So we're changing the password. That means the password is only stored in memory, and then the probes can pick that up, generate their definitions, and start executing them. So what it means here is like the CTP probe on this box, on my CAS server, is actually utilizing this mailbox right here. So if I just did a get mailbox, and I just put that in there, and what you'll notice is I have to also add this dash monitoring parameter, because like I said, we hide these monitoring mailboxes by default. And then, let's see, just pull out the relevant properties here. So if I get its UPN, I can get the server and the database that it's on. Then you can see where it's located. And so what you'll see is this is the actual backend that it's on. And why that's important is, again, if you wanted to go through the troubleshooting steps, if you're going through this model of how the protocols are actually organized, and you want to systematically work through, okay, great, I know the CTP is broken. If the proxy health test or the probe number 3 monitor was working, then presumably what would have to be broken is either the 1 or the 2 that over here. And then that's the app pool that you would go reset if it was 2. If it was 1, that means that it may be the app pool, but it also may be something in the store that's actually broken, and you'd start actually looking at the storage health sets to figure out, is this database corrupt? Do I need to fail it over? Is it even mounted? And that might be the issue of why that CTP probe is failing. And so if we were to do that here, what you'll notice is I now know the server. So when I do get health set, and I'm just going to do give me the ActiveSync health sets on that box. And what you'll see is I have the ActiveSync protocol health set and an ActiveSync health set. So that basically has my 1 and 2 probes that are on there. So this is basically how you can go all the way and get to seeing the whole picture, putting it all together. Now, what you'll also notice, I'm going to show you guys one more thing. If I look at the server, let me just look at the mailbox server and see if there's anything that's unhealthy on that box. So what you'll notice is I have 2. Data protection, because I haven't actually configured any clustering at all on the box, so that's okay. But you notice I have this mailbox space one that's also unhealthy. So if I go look at what's inside mailbox space, let's go pull that up. I'm going to go in here. And it says that the storage logical drive space monitor on my C drive is actually unhealthy. And I was actually quite puzzled when I saw this one. I actually had to get one of my devs to go take a look. It's because when I looked at my C drive on that box, let me just switch over here. If I look at the C drive, it says I have 20 gigs free. So that seems like a lot of space. I don't know why this thing's freaking out. But actually what happens is in our code, because this is in one of our test topologies, we actually configured that our threshold to be 100 gigs. You have to have 100 gigs free in order for this thing to be healthy. I guess it's so that we can actually push the boundaries and make sure this monitor flips. So in my case, I really don't need this monitor. So, and you may encounter situations where there are monitors that you just don't need. So how do you go get rid of monitors and you don't want them to go mark up your health sets as unhealthy when they're not relevant for you? Because I still want some of these other disk space or mailbox space monitors, so I don't want to turn off the whole health set. So the way that you do that is with overrides. And so in order to find the right setting for this override, again, we start with the monitor. So you have the name of the monitor. And in my slide examples, again, I'm showing you this is the long math way of how you could go find out what is the right thing so you can go create the right monitor. But I'm going to now show you the short way, which is basically what we can do is we can go into the event log. Actually, I'm on my CAS server, so let's go to the mailbox server. So if I go to the event log, I can just search for that health set or that monitor. So I go in here, I'll go into Microsoft Exchange, active monitoring. And again, the monitor definition, go run this thing, you'll remember is storage logical drive space monitor. That was the name of the monitor. So all I need to do is let me just go copy that. I'm going to go just search for it here. Just do Control F. Because I want to find that definition. And so in this definition, what you'll see here is the monitor definition ID is mailbox space, storage logical drive space monitor. And then the last one is the target. So when I'm actually defining a override, all I need is the first two. So if I was going to go and create an override for this, and with overrides, we actually have two options. You can create a global override, which is actually set in AD. So if I want to turn this off for every single server, I don't need this monitor, I could do a global one, or I could do a local one. And a local one, you can target for a specific server, and what it'll do is it'll create that override in the registry, so that when the service starts up, it'll then apply that override. So I'm just going to go and pull this thing out here. So now that I know what you'll see here when I paste it in. So see this? So I'm doing add global. It's probably hard to see at the very, very bottom. So I'm doing here add global monitoring override. So I'm adding this to the AD. This was that setting that I got from the event log, right? This mailbox space, storage logical drive space monitor. Oops. I should probably just do this on one machine instead of giving you guys whiplash going back and forth. And so the item type is a monitor. So the thing is, you can create overrides for anything, for a responder, for a probe. And so what we're doing is we know that this is the type monitor, so it knows which definition basically channel to go target. Then there's properties. So you can actually override any property you want in our definition. So we're doing the enabled property, and then we're going to set it to 0, which means we're going to make this thing not enabled. And currently, so the thinking was with overrides is that we would always have all the right settings. So any override you would need to do would be temporary. You'll never have to. That thing should expire because you'll go fix whatever your problem is, and then the system will go back to normal. Well, that was a little naive on our part. So we are removing the requirement to actually add a duration down the road. But currently, right now, you have to add a duration. So by adding 30, this says that this override will be valid for 30 days. And what it means is I need to go remember after 30 days to go reset this if I still need this override. The typical scenario really here was, you have this responder that is firing, but it's a hardware issue or there's an issue that is nothing that the local box can fix. So there's no need for this responder to keep firing over and over again. So you can go and create an override to disable that responder. You go resolve your issue, and then your responder would expire, like if you put it for 12 hours or a day, then it automatically starts coming up again. But we know now that there are situations where there are every environment will have its unique characteristics, and there are certain things you'll want to override indefinitely. So if I do this, what this will do is this will add an override. What happens is the service basically goes and reloads its configuration every 5 minutes. So in 5 minutes, it would go pull this as it goes through that bootstrapping process. It's going through reading, looking at the environment, figuring out what are the probes I should create, what are the monitors I should create. And when it does that, when it creates that definition, it'll apply the override to it. So it says, okay, I have a monitor definition, but now this is disabled. So if we don't want to wait 5 minutes, what we can do is just stop the health manager service. And then again, so basically what we're doing is just forcing that 5-minute cycle to come. And so when we start it, it's going to go through and apply the override. So again, what's happening here is, so when we're starting this up, there's actually quite a bit that's happening, right? Because we said, what we're doing right now is we're making sure that do we have monitoring mailboxes? We're going through and discovering the ones that we need. We're going through right now and resetting the passwords on them, and we're going to store them in memory on this box. So like this box only knows the passwords for those mailboxes. And then we're going to start the bootstrapping process. So I know that I need to go monitor ActiveSync. I need to monitor OA. So it's starting to create all the probe definitions. It creates all the monitor definitions to know what's the logic I should apply to those measurements. And then it's starting to create the responder definitions. So it knows, okay, I should make sure that when this thing goes unhealthy, this is what I'll do. So this is how our ideal case is, if you don't install a feature, ideally, those definitions don't get instantiated. But unfortunately, that is what happens is we don't create it, but you will still see some visible health sets even though that feature isn't there. And so that's the part that we have to do a little cleanup on. So if I go and rerun now this monitor, still unhealthy. Eventually, because like I said, it's still going through its bootstrapping. Eventually what you'll see is it'll basically appear disabled because it's not enabled. And if you really want to make sure, did this override really take effect? If you go through the long math method way of doing this, by actually pulling out the monitor definitions out of the channels, and then you search for the monitor definition, like logical drive storage space, when you dump that out, you will see the enabled property, and the enabled property will be 0. And that's how you know that will be disabled. So that's about it. I know it's a lot to cram in, especially the last session of the day. I appreciate your attention and sticking through it. But like I said, this is basically just one example, one of how to kind of systematically walk through managed availability, kind of see all the different pieces, see how they sort of fit together. We do have many devs from the monitoring team that are here this week. They're going to be at this Experts Unplugged session tomorrow morning. So if you have any other detailed questions or you want to walk through stuff, we're happy to do that with you. They also have hopefully some other exciting little tidbits and tools if you want some little tricks that we have. And I think we're showing some internal tools that we don't want recorded, which is why we're showing them tomorrow. That you can kind of see how we get some additional insight into managed availability. All right. Well, thanks a lot. We're ending 3 minutes to Mappy Beers. So I'm sorry I didn't leave a lot of time for questions.